Hey everyone, today we'll be discussing how to verify inverse functions algebraically. Let's start off with what an inverse function is. Here's a quick recap from a previous video, which I will link down below. Inverses are functions that undo each other. So if f of g of x equals x and g of f of x equals x, then f and g are inverses of each other. We will dive deeper into this. As you can see above, they both equal x. And why is that? Well, let's say f of x is x cubed. And to undo this x cubed, we would take the cube root. And as you can see, we do so in g of x. So these are actually inverses since they undo each other. Think of x as without any changes. In f of x, we cube it, the initial x, but in its inverse of g of x, it is undone as we took the cube root, resulting in x. So here's actually how inverses functions look like. As you can see, they're reflected along the line of x equals y. Let's move on to verifying inverse functions. So quick recap, if f of g of x equals x and g of f of x equals x, then they're inverses of each other. So let's say we have these two following functions and we have to verify that f of x and g of x are inverses. So step one would be to check that f of g of x equals x. So basically how that works is that as x, we plug in g of x for f of x. So as you can see, we did so. We did f of g of x, which is the cube root of x minus 5 divided by 2, and then since f, we plug that in to the x value of f of x, and as you can see, it is 2 times cube root of x minus 5 divided by 2 cubed plus 5, which is simplified to x minus 5 plus 5 equals x. So we can see that that f of g of x does equal x. Now let's check if g of f of x equals x. So as you can see, we just follow the same exact methodology and we get the result that it does equal x. So in fact, g of f of x are inverses of each other. Now let's look at this graphically. So in red is f of x, and in green is g of x, and in purple is a reflection. So they're inverses because they do reflect over the line x minus y and because they're one-to-one functions. Well, what is a one-to-one function? Well, we'll go over that in the next video. Thank you so much. Bye.